Okay, so when we set these up, when you say one thing is divided by another, like in this case, 672 is divided by 22, and we're going to do it without a calculator so that we can, again, refresh our division skills. Which one goes under the division piece? Okay, that's the division bar, or whatever you want to call it. Which one goes under it? The 672, okay? And then the 22 is going to go in the front, right? So we have two numbers in front, 2 digits. So we're going to have to look at the first 2 digits of our number that is under our division bar, the 67. And we start there and we say, okay, well, how many times does 22 divide evenly into 67? And you say 3. Okay. So we put a 3 above that 7, above that second digit. And then what do I do? Yeah, I got to drop down, but with what? Not yet. Where did I get 66 from? 22 times 3, right? So we take the number at the top and we multiply it by the number in front, and we get 66, and we put that under the 2 digits there. Does everybody kind of remember this? All right. And then what do? So subtract. So when we get into some polynomials, we're not going to just say subtract because we're going to have multiple terms. So you'll hear me say a lot, we're going to draw the line. And what I mean by that is I'm going to draw my little equal line, and then I'm going to change my signs. Well, here I only have one term, that's 66. But when we have multiple terms, we're going to change the sign of every term that we are subtracting. And then that way we can just combine them together. What is 67 minus 66? 1. And then what do I do next? Bring down the next piece, okay? And then I try again. How many times does 22 fit into 12? Nothing. So I've got to put that 0 at the top. We remultiply. 0 times 22 gives me 0. We subtract again, draw the line, change the signs. What is 12 called? Remainder. And when we write, or when we divide our polynomials, the way we're going to write our answer is we're going to write the 30 plus, we're going to write our remainder over our divisor, and the divisor is the 22 that we were dividing by. Okay, now we don't normally do that with numerical answers. Sometimes we would add a decimal and keep going, but we're going to be dividing polynomials, so we're not going to do that. We're going to write the 30, that's called the quotient, plus the remainder over the divisor. Okay, so we kind of all remember how to long divide? All right. So let's get into some polynomials now. If you'll take a minute and write that down. So when we set this up, the dividend, that's the one that we're dividing something into, goes under your division bar. So that, in this case, it's going to be the 6x squared plus 7x plus 2, okay? One thing you want to check before you get started is you want to make sure that you have a representative of every degreed term there is. So meaning if I start with an x to the third, I have to have an x squared, I have to have an x to the first, and then I have to have a constant term, okay? In this case, my highest degree is an x squared, so I need to make sure I have an x, which I do, and also a constant term with no variable, which I also have, okay? If you don't have some of those, which we'll get to in a few minutes, we'll have to put in a placeholder, okay? And then that 2x plus 1 is going to go in the front. Okay, now you're looking at that and say, well, how in the world am I supposed to tell how many times 2x plus 1 goes into that thing? Okay, we don't focus on the entire polynomial. We focus on the first terms only. Now, normally when I'm doing this, I'll do it on the board and I use my fingers because it helps me keep straight what I'm doing, but I got to have a video, so we're going to use a highlighter. So I'm focused on just the first terms. How many times does 2x go into 6x squared? Or let's change that. What do I multiply 2x by to turn it into 6x squared? 3x. So when we put that 3x at the top, because there are two terms that I'm dividing by, the 2x plus 1, I'm going to put it over the second term in my of my division bar. So I'm going to put 3x right above that 7x. Now, the placement in this isn't extremely important, but you just put it over however many terms you're dividing by. Okay? So far, so good. All right, then the next thing we're going to do, just like we did with that 3, was we multiply that top number, that 3x, but I'm going to multiply it by both pieces here. I'm multiplying it by the 2x and by the 1. So 3x times 2x gives me 6x squared. And then 3x times positive 1 gives me a positive 3x. Is everybody okay with that? All right. Now, this is when draw the line, change the sign helps out instead of just saying subtract, because we have multiple terms. So what I'm going to do is I'm going to draw my equals line, and then I'm going to change the sign of every term. So this 6x squared, the second one, is going to be turning into a negative, and this positive 3x is also going to turn into a negative. And now I can just add straight down. The goal is that first term should always cancel out, okay? 6x squared and negative 6x squared is going to cancel. But if I add a 7x and that negative 3x, what is that going to give me? That's going to give me 4x. Then what do you think I should do? Bring down that plus 2, okay? Don't forget your sign, because we still have to have two terms. In order for me to divide two terms, I have to have two terms for them to divide into. And then we start the process over. Again, focusing on the first terms only. What do I multiply 2x by to make it turn into 4x? 2. Positive 2 or negative 2? Positive. So we're going to put a plus 2 up here. And then we're going to remultiply, but just by the 2. This 2 gets multiplied by the 2x, which gives me 4x. And then the 2 also gets multiplied by the 1, which gives me a plus 2. Bless you. And then we are going to draw the line and make sure you change every sign. If you forget to change all of the signs, you're going to end up with the wrong answer, and it's probably going to turn into a mess. Okay, 4x and negative 4x disappear. What do 2 and negative 2 also do? They disappear. They cancel out. So my remainder this time is 0. Well, if your remainder is 0, you do not have to include it. So your quotient, the answer to your division problem, is going to be the 3x plus 2. There is no remainder to add behind it, so we just leave our answer like that. You guys kind of remember doing this before? If you take it slow, one piece at a time, yes, I know sometimes they seem a little complicated and a lot of work, and one little sign error or one little addition error or subtraction error is going to make the whole thing wrong. But you just, if you're careful and go one piece at a time, it shouldn't be too terribly difficult. You ready? Okay. Okay, we'll take a look at this one together, and then I'll let you practice one. We've got 4x squared plus 23x minus 16 that we want to divide by x plus 5. So the first thing we need to do is set it up as a long division problem. Also, when you're setting it up, make sure you're not missing any terms. It's going to be in standard form, highest degree first, and you have to have a representative for every degree below that. So I have an x plus 5, so that's a single x to the first, and a constant, so I'm good there. I'm dividing by 4x squared plus 23x minus 16, so I'm not missing any degree terms there. And then again, we focus on the first terms only. What do I multiply x by to turn it into 4x squared? 4x. Okay, so that's going to go at the top. Then we're going to take that 4x and multiply it by both the x and the positive 5. 4x times positive 5 is a positive 20x. I'm going to draw the line and change every sign. So that 4x squared turns negative, and so does that 20x. We can go ahead and combine our terms now. A 4x squared and a negative 4x squared cancel like they're supposed to. A positive 23x and a negative 20x, what is that going to give me? Positive 3x. Then we want to bring down that negative 16. and we start the process over. Looking at the first terms only, what do I multiply x by to turn it into 3x? Positive 3 or negative 3? Positive, so we're going to put a plus 3. And then we're going to multiply again. That 3 gets multiplied by the x and the 5, so that becomes 3x plus 15. We're going to draw the line and change every sign. My 3x's are going to cancel. What does negative 16 and negative 15 give me? Negative 31. So this time I do have a remainder. Is everybody okay so far? All right, the way we write our answer is the quotient. That's the piece at the top, the 4x plus 3. And then we're going to write plus our remainder, but my remainder happens to be negative, over what I divided by, my divisor. That's x plus 5. Okay. You could also write this as 4x plus 3. And since my remainder is negative, you could also write it as a minus 31 over x plus 5. Either one of these would be an acceptable answer. You could keep it as plus and negative if you want to, or you can change it to minus. Anybody have any questions?
Negative 31.
Because I added the negative 16 and the negative 15. Because when I subtract, let me erase, hold on.
Positive 15, I don't even really got that.
Okay. So what I'm doing is I am taking, to get that 3x and that 15, I'm taking this plus 3 that I have here at the top, and I'm multiplying. I'm multiplying it by the x. That gives me this first 3x. Then I multiply it by the 5, which gives me a positive 15. But then when you subtract, you have to subtract each piece, so we just change the signs of those. That way we can just add. Does that make sense? Okay. Everybody else good? All right. Okay, you are not missing any pieces. I'm going to set it up. The x minus 7 goes on the outside. 3x squared minus 29x plus 56 goes on the inside. And we're going to start with the first terms. What do I multiply x by to turn it into 3x squared? 3x, okay. We multiply that 3x by the x. That gives me 3x squared. We multiply 3x by that negative 7, and that gives me a negative 21x. We're going to draw the line and make sure we change all of our signs. In this case, there's 2 of them that change. When I combine my terms, the 3x squared and the negative 3x squared cancel out, and here's where the mistake happens. If I have a negative 29x and a positive 21x, what am I left with? Negative 8, okay? So make sure you check your answers. A lot of you had a positive 8 right there, okay? Not the answers, but check your work. You should have a negative 8x there, and then bring down that plus 56. And then, again, starting with the first terms only, what do I multiply x by to turn it into negative 8x? A negative 8, so I got to put a minus 8 at the top. And when we multiply, negative 8 times x gives me negative 8x. Negative 8 times negative 7 is a positive 56. And then we are going to draw our lines and change both of our signs. The 8x's cancel. The 56's also cancel. So my remainder is going to be 0. So my final answer should be 3x minus 8. A lot of you have plus 8 there, so be careful with that. Be careful when you are combining your terms that you bring the signs that are needed. Okay? And what I'm talking about is this one in particular right here. It needs to be a negative 8x, not a positive 8x. Is everybody okay with that? Let me see. Hold on. See what all I got here. Okay. Try 4, and then we'll talk about 5. That one's missing a little bit in a minute. Whoops. The x minus 1 goes first. On the outside, 9x squared minus 21x minus 20 goes on the inside. What do I multiply x by to turn it into 9x squared? 9x. Multiply that 9x by x minus 1. That gives me 9x squared minus 9x. When I draw my line, make sure you change every sign. The 9x squareds cancel. Now, if I combine a negative 21x and a positive 9, what is that going to give me? What? Negative 12. I'm going to bring down that minus 20. And then I'm going to focus again. What do I multiply x by to turn it into a negative 12x? Negative 12, yep. So I'm going to put minus 12 at the top. We multiply that negative 12 by the x and the negative 1. So that's going to give me a negative 12x, and that's going to give me a positive 12. I'm going to draw my line, change every sign. The 12s cancel. Negative 20 and negative 12 gives me a negative 32. That's my remainder. So when we write our answer, it's our quotient. It's that 9x minus 12 first, plus your remainder over your divisor, but my remainder happens to be negative, so we can either write it as plus a negative 32 over my divisor of x minus 1, or we could just write it as 9x minus 12 minus a 32 over x minus 1. Either one of those is okay. Make sure your signs are correct. If not, I saw, I think, 1 or 2 people that missed the whole negative 12 thing, put positive 12 there, but just be careful with those. If you take it slow, one step at a time, that's how you kind of help not to make any mistakes instead of trying to rush through. All right, let's take a look at 5. This one's going to need a little bit of work. It's also going to be a little bit longer. I got 4x to the 4th minus 2x to the 3rd minus 3x minus 9, and then I'm dividing that by 2x squared minus x minus 3. So when we set this up in a division problem, let's look at the divisor, the 2x squared minus x minus 3. Am I missing a term on that one? I have an x squared, I have an x, and a constant, so I'm not missing anything there. So I'm going to go ahead and write that as it is on the outside. And yes, it's 3 terms. Process is still the same. But when I put that dividend under my division bar, I start with my highest term, 4x to the 4th. I do have an x to the 3rd, so I'm going to write that down. What do I not have? I don't have an x squared. Okay, because we're missing that variable with that exponent, that term, we have to put in a placeholder. What's a placeholder? Numerically, what's a placeholder? 0. Okay, so what we're going to do is we're going to put plus 0x squared. You could put minus 0x squared if you want to. I usually just put plus. But I'm putting in a 0x squared. That's going to hold the place for the x squared position. Because if not, and you start trying to divide, you're going to end up with terms that aren't the same that you can't combine. Then I have my x term, which is a negative 3x. And then I have my constant term, which is just 9. Okay, so I just had to add in a placeholder because I was missing the x squared term. So I had to put in a 0x squared to hold its place. Now the process is exactly the same. Even though it looks a little bit different, my divisor is longer. We're still focusing on the first terms only. What do I multiply 2x squared by to turn it into 4x to the 4th? 2x squared. And I'm going to put that over the 3rd term here since there are 3 terms that I'm dividing by. Again, the placement of that isn't really that important, just as long as you line up all your terms when you're multiplying. So we're going to take that 2x squared at the top and we're going to multiply it by each one of those 3 terms in the front. 2x squared times 2x squared gives me 4x to the 4th. Then 2x squared times a negative x is a negative 2x to the 3rd. And then 2x squared times negative 3 is a negative 6x squared. Everybody ready? Draw your line, change all of your signs. Okay, this time I have 3 terms, so I need to change every sign. The 4x to the 4th, the negative 2x to the 3rd, and the negative 6x squared are all going to change. 4x to the 4th and negative 4x to the 4th cancel out. What also happens to my x to the 3rds? What do they do? They also cancel, okay? That's okay. Then I add my x squared. 0x squared plus 6x squared is going to give me 6x squared. Okay. I'm going to bring down that next term. Now here's where we run into a little bit of difficulty as well. Can 3 terms fit into 2 terms? No, you have to have the same number of terms. You could put 0 up at the top and then keep going. However, if you put a 0 in front of a variable, you're not going to write it in your final answer, right? So since I have 3 terms right here and I only have 2 terms here, I'm going to go ahead and bring down that -9 as well. Okay, because I have to have 3 terms to divide 3 terms into, if that makes any sense. So I'm going to go ahead and bring down that -9. Because in my final answer, I don't need placeholders. I just need placeholders to divide. And we're going to start over again. What do I multiply 2x squared by to turn it into 6x squared? Positive 3 or negative 3? Positive 3. So I'm going to put a +3 at the top. And then I'm going to multiply that +3 by everything in the divisor. So that's going to give me 6x squared minus 3x minus 9. And then I'm going to draw my line and change every sign. What's my remainder going to be? 0. So my final answer is just the 2x squared plus 3. Okay, so just be careful when you're setting your problems up. Look at your highest degree. Make sure you have a term for every degree below that. If not, put in a 0. What that does is that just keeps your terms lined up so that it doesn't get confusing when you start dividing everything out. Is everybody okay with that? All right, I have one more thing we're going to do. It has to do with the dividing. They're going to ask, is x plus 1 a factor of 3x to the 4th minus 4x to the 3rd plus 12x plus 5? Okay? You're going to answer either yes or no, but you're going to have to do some work first. So in order to determine if x plus 1 is a factor of that other polynomial, does anybody know how we can tell that? If what equals 0? So how to tell if it's a factor? You divide. If your remainder is 0, that means it goes in evenly and there's nothing left over. That's what a factor is, right? So if I think about, if I say, is 2 a factor of 6, you would say yes, because 2 divides evenly into 6. But if I said, is 4 a factor of 6, you would say no, because 4 does not divide evenly into 6, okay? So in order to determine if something is a factor, we're going to divide it. If my remainder is 0, the answer is yes, it is a factor. If the remainder is not 0, then your answer is no, it is not a factor. Okay, so let's first of all set this one up to divide. Be careful when you're setting up your dividend, and when your dividend is the thing you're dividing into. Okay, be careful when you're setting that up in your division problem. I have an x to the 4th, I have an x to the 3rd, I have an x squared, but what do I not have? You don't have a single x. So when you set it up, make sure you put your placeholder in. Now, you can't hardly see that I there, can you? So we're going to set x plus 1 out front. We're going to go 3x to the 4th minus 4x to the 3rd plus 12x squared. But because I don't have an x, what am I putting in there? 0, and then bring down that 5. So what I want you to do is I want you to take a couple of minutes and divide it out. If your remainder is 0, your answer is going to be yes. Well, there we go. What do you think, yes or no? Okay, we're here no. I'm going to write that over here and we'll do our work to see. What do I multiply x by to turn it into 3x to the 4th? 3x to the 3rd. Then I multiply that. That gives me 3x to the 4th plus 3x to the 3rd. I'm going to draw my line and change every sign. Those cancel. Negative 4x to the 3rd and negative 3x to the 3rd gives me negative 7x to the 3rd. I bring down my next term. Do I need any extra terms or do I have enough right there? 2 terms and 2 terms. That's enough, right? So I don't need to bring any extras. All right, starting back over. What do I multiply x by to turn it into negative 7x to the 3rd? Yep. Well, there, negative 7x squared. We're going to multiply. That's going to give me negative 7x to the third minus 7x squared. We're going to draw our line and change our signs. 12x, the 7x's cancel. 12x squared and 7x squared gives me 19x squared. I'm going to bring down that 0x. Starting over again, what do I multiply x by to turn it into 19x squared? We multiply, we get 19x squared plus 19x. We draw the line, we change our signs, those cancel. 0x minus 19, or plus a negative 19x squared is negative, not squared, just 19x. Bring down that plus 5. Starting the process over, what do I multiply x by to turn it into negative 19x? Negative 19. And when we multiply, we get negative 19x minus 19. I draw my line, I change my signs, my x's cancels, but that gives me a remainder of 24, which means the answer is no. It does not divide in evenly because I have a remainder other than 24. So that's all we have to put in our answer blank is no, it is not a factor. If your remainder is 0, you would say yes.